According to the National Electrical Code, the minimum height for a circuit breaker panel from the finished floor or ground level is 24 inches. This applies to both indoor and outdoor locations. While concealing the panel inside a Rubbermaid shed might seem like a temporary solution, it is generally not recommended. The NEC requires electrical panels to be accessible for servicing and maintenance. If the panel is concealed within a shed, it may be difficult to reach in an emergency. When installing the circuit breaker panel for the outdoor baptistry, it is important to consider several factors. Firstly, weather protection is essential. The panel should be mounted in a weather-resistant enclosure to protect it from rain, snow, and other elements. Secondly, accessibility is key. The panel should be easily accessible for maintenance and servicing, even during inclement weather. Thirdly, the minimum height for the panel above the finished grade should be 24 inches. The 1.5-inch conduit should be adequate for a sub-panel that will supply 4 outlets and a sign. However, it is crucial to properly size the wire based on the total load of the sub-panel. Additional considerations include conduit burial depth. The 2-inch polyvinyl chloride conduit should be buried at a minimum depth of 18 inches. Appropriate conduit fittings should be used to connect the conduit to the panel and sub-panel. Properly grounding the circuit breaker panel and sub-panel to the electrical system is a must. For the best safety and code compliance, it is highly recommended to adhere to the minimum height requirement of 24 inches for the circuit breaker panel. Concealing the panel inside a Rubbermaid shed is not advisable. Consider installing the panel in a weather-resistant enclosure that meets the NEC requirements for accessibility and protection from the elements. When running the 2-inch polyvinyl chloride conduit from inside the church to the outside and coming up from an 18-inch depth to a circuit breaker panel over a distance of 165 feet, several factors need consideration. If number 2 THHN wire is used, the minimum height permissible for the panel should comply with electrical codes. The National Electrical Code mandates a minimum height of 24 inches from the finished floor or ground level to the bottom of the circuit breaker panel. This applies regardless of whether the installation is indoors or outdoors. While temporarily concealing the panel inside a Rubbermaid shed might seem convenient, it is not a recommended practice due to accessibility requirements for servicing and maintenance. For a more permanent solution, especially when planning for an outside baptistry, weather protection is paramount. The panel should be housed in a weather-resistant enclosure to shield it from rain, snow, and other environmental elements. Accessibility remains crucial, ensuring that the panel can be easily reached for maintenance, even during unfavorable weather conditions. Remember, the minimum height of the panel above the finished grade should still be 24 inches. As for running a 1.5-inch conduit to a sub-panel 222 feet away for 4 outlets and a sign for the church, several aspects must be considered. The conduit size itself may be adequate, but the wire size within the conduit is determined by the total load of the sub-panel. A load calculation must be performed to determine the appropriate wire gauge to prevent overloading and ensure safety. Concerning conduit burial depth, the 2-inch polyvinyl chloride conduit should be buried at a minimum depth of 18 inches, as per NEC guidelines. When connecting the conduit to both the main panel and the sub-panel, ensure the use of appropriate conduit fittings to maintain a secure and weatherproof seal. Grounding is a fundamental safety requirement. Both the main circuit breaker panel and the sub-panel must be properly grounded to the electrical system, providing a path for fault currents and minimizing the risk of electrical shock. In summary, adhering to the minimum height requirement of 24 inches for the circuit breaker panel is strongly recommended for safety and code compliance. Avoid concealing the panel inside a Rubbermaid shed due to accessibility concerns. Instead, opt for a weather-resistant enclosure that meets NEC standards for both accessibility and environmental protection. Finally, ensure that all wiring and connections are performed by a qualified electrician to guarantee safety and adherence to all applicable electrical codes. Let's delve deeper into the specific requirements and best practices for installing electrical panels, focusing on safety, code compliance, and longevity of the installation. Firstly, let's reiterate the importance of the 24-inch minimum height requirement for circuit breaker panels. This height is not arbitrary. It is designed to prevent accidental contact with live electrical components, particularly in damp or wet environments. Additionally, it provides a reasonable level of accessibility for technicians performing maintenance or repairs. Ignoring this requirement can lead to code violations and, more importantly, increase the risk of electrical shock. Secondly, concerning the temporary concealment of the panel within a Rubbermaid shed, the primary concern is accessibility. Electrical panels require periodic inspection, maintenance, and potential repairs. Then closing the panel within a shed can hinder access, especially in emergencies or when quick troubleshooting is needed. Moreover, sheds are typically not designed to provide adequate ventilation, which can lead to overheating of the electrical components within the panel, potentially causing premature failure or even fire hazards. Instead of concealing the panel in a shed, consider investing in a weather-resistant enclosure specifically designed for outdoor electrical installations. These enclosures are typically made of metal or durable plastic and are designed to protect the panel from rain, snow, dust, and other environmental factors. They also provide adequate ventilation to prevent overheating and are equipped with locking mechanisms to prevent unauthorized access. Thirdly, when planning the installation for the outdoor baptistry, meticulous attention to detail is essential. The environment around the baptistry is likely to be damp or wet, so weather protection is even more critical. Ensure that the enclosure is rated for outdoor use and is properly sealed to prevent moisture from entering the panel. Consider using a ground fault circuit interrupter, protected circuit for all outlets near the baptistry to further enhance safety. Also, take into account the potential for physical damage to the panel. Install it in a location where it is unlikely to be struck by vehicles or other objects. If necessary, provide additional protection in the form of bollards or barriers. Moving on to the sub-panel installation for the church sign and outlets, proper load calculation is paramount. Before selecting the wire size for the 1.5-inch conduit, calculate the total amperage draw of all connected loads, including the sign and the 4 outlets. Allow for future expansion by adding a safety factor of at least 25% to the calculated load. Consult the National Electrical Code, Table 310.15. B16 to determine the appropriate wire gauge for the calculated load and the specific type of insulation used, such as THHN. Keep in mind that the length of the run, 222 feet, can also affect the wire size due to voltage drop. Voltage drop occurs when the voltage at the end of a long wire run is lower than the voltage at the source. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. Use a voltage drop calculator to ensure that the wire size is adequate to maintain the voltage within acceptable limits, typically no more than 3% voltage drop for branch circuits. Furthermore, when burying the 2-inch polyvinyl chloride conduit, the minimum depth of 18 inches is crucial for protecting the conduit from physical damage. This depth is specified by the NEC and is intended to prevent the conduit from being damaged by vehicles, landscaping equipment, or other activities. If the conduit is installed in an area where it is likely to be subjected to heavy traffic, consider increasing the burial depth or using a more robust type of conduit, such as rigid metal conduit. When connecting the conduit to the panels, use appropriate conduit fittings that are listed for the specific type of conduit used. Ensure that all fittings are properly tightened to create a watertight seal. Use thread sealant on threaded fittings to prevent leaks and corrosion. Finally, proper grounding is non-negotiable. Grounding provides a low impedance path for fault currents, which helps to protect people and equipment from electrical shock. Ground the circuit breaker panel and sub-panel to a grounding electrode system, which typically consists of ground rods, metal water pipes, or a concrete-encased electrode. The grounding electrode system should be properly sized and installed in accordance with NEC requirements. In addition to the grounding electrode system, ensure that all metal parts of the electrical system, such as conduit, enclosures, and equipment, are bonded together to create a continuous ground path. Use grounding bushings and bonding jumpers to ensure that all connections are secure and properly tightened. By following these guidelines and adhering to all applicable electrical codes, you can ensure a safe, reliable, and long-lasting electrical installation for the church and its facilities. Remember, electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. Let's elaborate further on the practical aspects of circuit breaker panel installation, focusing on specific techniques and best practices that enhance safety and reliability. First, the selection of the right type of circuit breaker panel is crucial. Consider the total load requirements of the church, including current and future needs. Choose a panel with sufficient capacity to accommodate all circuits and appliances without overloading. Overloading a circuit breaker panel is a serious fire hazard. Ensure the panel is rated for the appropriate voltage and amperage for the electrical system. Secondly, when mounting the circuit breaker panel, whether indoors or outdoors, the mounting surface must be sturdy and level. Use unistrut or similar mounting hardware to securely attach the panel to the wall or other support structure. Ensure that the panel is mounted plumb and level to facilitate proper operation of the circuit breakers. When mounting the panel outdoors, consider using a weatherproof backboard to provide additional protection from moisture and corrosion. Thirdly, wiring the circuit breaker panel requires meticulous attention to detail. Use only approved wiring methods and materials. Ensure that all wires are properly sized for the circuit amperage and voltage. Follow the NEC color coding conventions for wiring. Black or red wires are typically used for hot conductors, white wires are used for neutral conductors, and green or bare wires are used for ground conductors. When connecting wires to circuit breakers and terminals, strip the insulation to the proper length and use a torque screwdriver to tighten the screws to the manufacturer's specified torque. Over-tightening or under-tightening screws can lead to loose connections and overheating. Fourthly, when installing circuit breakers, ensure that they are properly sized for the circuits they protect. Use only circuit breakers that are listed and labeled for use in the specific circuit breaker panel. When replacing circuit breakers, use the same type and amperage rating as the original circuit breaker. Never replace a circuit breaker with a higher amperage rating, as this can overload the circuit and create a fire hazard. Fifthly, labeling the circuit breakers is essential for easy identification and troubleshooting. Use a circuit breaker directory to clearly label each circuit breaker with the corresponding circuit it protects. Update the directory whenever circuits are added or changed. Consider using a label maker to create professional-looking labels that are easy to read and durable. Sixthly, proper grounding and bonding are critical for safety. Ensure that the circuit breaker panel is properly grounded to the grounding electrode system. Bond all metal parts of the electrical system together to create a continuous ground path. Use grounding bushings and bonding jumpers to ensure that all connections are secure and properly tightened. Seventhly, inspect the circuit breaker panel regularly for any signs of damage or wear. Look for loose connections, corroded terminals, cracked insulators, or other problems. If you find any problems, have them repaired by a qualified electrician immediately. Eighthly, keep the circuit breaker panel clean and free of debris. Dust, dirt, and other debris can accumulate inside the panel and cause overheating or other problems. Use a vacuum cleaner or compressed air to clean the panel regularly. Ninthly, never work on a live circuit breaker panel unless you are a qualified electrician. Working on a live panel can be extremely dangerous and can result in serious injury or death. If you need to work on the panel, turn off the main circuit breaker to disconnect power to the panel. Tenthly, always follow all applicable electrical codes and regulations. The NEC is the primary source of electrical codes in the United States. Consult the NEC and your local electrical codes to ensure that all electrical work is performed safely and in compliance with the law. By following these best practices and adhering to all applicable electrical codes, you can ensure that the circuit breaker panel is installed safely, reliably, and in compliance with the law. Remember, electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. Now let's delve into some advanced topics related to electrical panel installations, including surge protection, arc fault circuit interrupters, and energy efficiency considerations. Firstly, Surge protection is an important consideration for protecting sensitive electronic equipment from voltage spikes. Voltage spikes can be caused by lightning strikes, power surges from the utility company, or even by turning on and off certain appliances. Surge protectors work by diverting excess voltage away from the protected equipment. There are two main types of surge protectors: whole house surge protectors and point-of-use surge protectors. Whole house surge protectors are installed at the main circuit breaker panel and protect the entire electrical system from voltage spikes. Point-of-use surge protectors are plugged into individual outlets and protect specific appliances or electronic devices. Consider installing a whole house surge protector to protect the church's electrical system from voltage spikes. Also, use point-of-use surge protectors to protect sensitive electronic equipment, such as computers, audio equipment, and video equipment. Secondly, arc fault circuit interrupters are another important safety device for protecting against electrical fires. Arc faults occur when electricity jumps from one conductor to another, creating a spark. These sparks can ignite flammable materials and cause a fire. Arc fault circuit interrupters are designed to detect arc faults and quickly shut off the power to the circuit, preventing a fire. The NEC requires arc fault circuit interrupters to be installed in all branch circuits that supply bedrooms, living rooms, dining rooms, and other areas where people are likely to be present. Consider installing arc fault circuit interrupters in all branch circuits throughout the church to provide enhanced protection against electrical fires. Thirdly, energy efficiency is an important consideration for reducing electricity costs and minimizing environmental impact. There are several ways to improve the energy efficiency of the electrical system, including using energy-efficient lighting, installing occupancy sensors, and using programmable thermostats. Energy-efficient lighting, such as light-emitting diode lamps, use significantly less electricity than traditional incandescent lamps. Occupancy sensors automatically turn off lights when a room is unoccupied, saving energy. Programmable thermostats allow you to set different temperatures for different times of the day, reducing energy consumption. Consider implementing these energy efficiency measures throughout the church to reduce electricity costs and minimize environmental impact. Fourthly, when planning the electrical system for a new building or renovation project, consider using a smart home system. Smart home systems allow you to control various aspects of the electrical system, such as lighting, temperature, and security from a central location. Smart home systems can also provide energy savings by automatically adjusting lighting and temperature based on occupancy and time of day. Consider installing a smart home system in the church to provide enhanced control and energy savings. Fifthly, when installing electrical equipment in damp or wet locations, use only equipment that is listed and labeled for use in those locations. Use weatherproof enclosures, conduit fittings, and wiring methods to protect the electrical equipment from moisture. Ground fault circuit interrupter protection is required for all outlets in damp or wet locations. Sixthly, when working on electrical equipment, always wear appropriate personal protective equipment such as safety glasses, rubber gloves, and insulated tools. Never work on electrical equipment while standing on a wet surface. Always turn off the power to the circuit before working on any electrical equipment. By following these advanced guidelines and adhering to all applicable electrical codes, you can ensure that the electrical system is safe, reliable, energy efficient, and in compliance with the law. Remember, electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns.